Okay, we'll go with that. So you will have seen my talk title today is the Foraging Ecology of Antarctic Snow Petrels, which sounds quite highbrow, but really what I'm here to talk about is the very glamorous world of bird vomit science. As you'll see, this is quite a messy subject, but one I'm very fond of and really looking forward to talking about. As Chris said, I'm a PhD student with Durham University and the British Antarctic Survey, and just before we get into the talk proper, I'm going to talk about my other hat, which is I'm the current co-president of the UK Polar Network. And the UK Polar Network is the UK's base for APEX, which is the Association for Polar Early Career Researchers. So if there's anyone here who's undergraduate, postgraduate, at least within 10 years of their PhD, we are a networking group where we offer outreach, we offer training, and we offer opportunities to meet with other early and later career polar scientists, and I'm happy to chat to anyone about that afterwards. On Thursday in Durham, in partnership with the Core Northeast Fund, we have a panel on fieldwork in polar regions, which I'm sitting on, so you're very welcome to come along to that, again, if you are an ECR scientist. So, to get into the talk, I am very privileged to study a species called a Snow Petrel, and I'm doing my PhD on them. So my PhD is with Durham, Bass, in the British Antarctic Survey, and I work on a project called ANTSEA, so Antarctic Sea Ice Evolution from a Novel Biological Archive, which is the brainchild of this professor here. This is Professor Aaron McClymont at Durham, and my funding comes from the European Research Council, and the data I'm going to show you today was collected at the International Polar Foundation's base, the Belgian Antarctic base in Antarctica, and the MPI, the Norwegian base, Troll in Antarctica as well. A little bit of background about myself. So I am Irish. I am previously a geologist and a paleobiologist, but I've stepped into marine ornithology for my PhD. Before we get... Oh yes, very briefly, what I'm about to present has not been published. I'm very keen for it to soon be published. So if this symbol is on the screen, please do not share any pictures of it online just yet. Give me a few weeks. So, this, will it play? Just mute that very quickly. This bird here, in this really amazing vista, is the Snow Petrel. So these are small, all-white petrels with very distinct black beaks, black eyes and black legs that only live on the Antarctic continent and some of the subantarctic islands. And what you're seeing here are flocking snow petrels on an iceberg in the Weddell Sea. And if you look closely, you'll see a few of them are actually having snow baths on it, which is one of my favourite behaviours that these birds have. So despite the fact that they look like these beautiful angelic little birds, when you see them at the colony, they tend to be absolutely filthy, and especially in the hand as well. And then they head out to the coast to feed, and they come back sparkling white because they spend so much time rolling around in the snow, and it is incredibly endearing. Can I get the next slide to appear? So yeah, again, what I said, they are endemic to Antarctica, and one of the most characteristic attributes of the Snow Petrel is that they are incredibly pagophilic. And what pagophilic means is that they are highly associated with the sea ice itself. So their name, Pagodroma nivea, is ice runner. And the association of Snow Petrels with sea ice has been known pretty much since the first exploration into the Antarctic, and sailors would use them as markers for how far they were from sea ice or whether or not they were finally getting away from the sea ice because the Snow Petrels would disappear. Now, although they live in very close association with the sea ice for feeding, they have to nest on exposed ground. They're not like the emperor penguins where they can have their chicks on ice. They have to be on rocky areas. And what you get in Antarctica is you have the big expansive ice sheet, but then you have the tips of mountains protruding through that ice sheet, and they're what's known as nunataks. And that's where you're going to get the snow petrel nests. Snow petrels are full marine petrels, so what this means is that they have a very prominent sort of two nostrils up on top of their beak. So if anyone's familiar with northern fulmars, that's the equivalent. The only northern hemisphere full marine petrel that we have up here. If anyone is very, very familiar with northern fulmars, you'll know that they have an interesting habit, which is, as a defense mechanism, they will actually spit at skuas, at conspecifics, so members of the same species, at seabird researchers who just want to put a ring on them. And what they're spitting at you is digested dietary material. So they're spitting the broken down fats that they've taken from the krill, from the squid, and from the fish that they feed on. It's very smelly, it's very hard to get off, and it's very sad when it gets on your favourite boots because they're gone. And snow petrels are in that same family, and so they have the same abilities as well. They are defensive spitters. Now, unlike northern fulmars who are going to nest on the wet cliffs of the UK and Ireland, snow petrels live in Antarctica. And Antarctica, which surprises some people, is actually a desert. You're not getting heavy rain, and in most places you're not actually even getting that much snow. And what this means is that when the snow petrels spit, it's not going to go anywhere. There's not going to be any active weathering to remove it. So it's going to build up slowly over time. As a result, around snow petrel nests, and they'll nest in crevices around the rocks on these nunataks, you're going to get these huge expanses of stomach oil building up all around their nests. And this can be upwards of 1 metre thick. It can be quite deceiving in the field because you think you're looking at what's just a rocky surface, but then as your eyes get a little bit more focused, you start to see that some of that rock looks almost like candle wax. And what you're seeing there is the built-up stomach oil deposits. They can be upwards of 1 metre thick. I've got a colleague in the front row here, Tal, and Tal actually works on a stomach oil deposit that in our research group we have nicknamed the Beast, because it is about 90 centimetres tall, as far as I know. And as you're walking around the colonies, your foot can be slipping into these. It does come up, the temperature does rise above freezing in Antarctica, so they get a little bit mushy. And these are digested remains of fish. And so you can imagine, if you'd like to, the smell that can come off of some of these deposits on what could be considered a hot day in Antarctica, or when you've stored them in a fridge in Durham. Now, just before we get into a little bit deeper into the talk, I'm just going to sort of check some definitions. You'll hear me use words like ice sheet, sea ice, and ice edge. The ice sheet is the ice that sits on top of land in Antarctica. So an ice sheet is a big, expansive, massive ice that's sitting directly onto the terrestrial. So think Greenland, Antarctica. The sea ice itself is the frozen seawater that floats on the ocean surface. So the snow petrels live out on the ice sheet, but they depend on the sea ice itself for feeding. The ice edge, when I talk about the snow petrels tend to go to the ice edge, isn't a very strictly delineated boundary. You don't just get ice water in Antarctica. You're going to have lots of ice, a little bit less ice, a little bit less ice, a little bit less ice, no ice, some ice, not much ice. And then eventually you'll get into what can be classed as the open ocean. And so when we talk about species like snow petrels being dependent on this ice edge, this is a very diffuse zone. And pagophilic, yeah, you all learned what that meant earlier. It means that they're ice associated. So here is the Beast itself. That's the big deposit that Tal has worked on. And if you look carefully at it, and remember this is just frozen vomit from these seabirds, there's actually layers in it if you squint. So you can imagine it's almost like a peat core, or maybe the layers in a tree ring, or even if you want to associate it with food, like a birthday cake. And what makes these deposits really special is that they get very old. So because this is Antarctica, again, you don't get much weathering. There's not much animals other than the snow petrels and a few other flying seabirds themselves that are going to disturb them. So they can remain in situ for millennia. And we have dated several of these deposits that have been past radiocarbon dating, so they are at least 40,000 years old. It's a lot of very old spit. Now, the thing is, these deposits are coming purely from the petrel's diet. So these deposits are a record of what the snow petrels have been eating through time. As I said, these are layers. These are layered deposits, so we can use radiocarbon to get the times of when the snow petrels were eating what, and then we can trace that back through time and see what changes have been occurring. And as I said, the snow petrels, their diet is incredibly associated with the sea ice itself. They have to be in a sea ice zone to feed. These deposits are only laid down when the snow petrels are raising their chicks. So they don't spend the winter at the colony, they just spend the summer period there when they are raising their chicks. So they can only travel so far out into the ice to get food to bring it back for the chicks. So we have a spatial constraint of where the snow petrels are going. We know that they're feeding primarily in sea ice, and we have a time. You might see where I'm going here, which is that if we have shifts of snow petrel foraging ecology recorded through time, this might be a way of recording past sea ice conditions. Now, in Antarctica, the state of the sea ice is very, very variable. So the past 2 years, we've had record minima of sea ice, where we've had very, very little sea ice, and it's receded very, very quickly during the summer. And this can have massive knock-on impacts on the ecosystems in Antarctica and in the rest of the oceans themselves, because the primary production that's occurring in Antarctica is going to affect global oceans. So having a better idea of what's happened to the sea ice over the past few millennia will allow us to better model what is going to happen to the sea ice in the coming hundreds and thousands of years. So this archive here is an invaluable record of past sea ice conditions in a continent where we don't get to do stuff like ocean coring because it's inaccessible, and where you might have issues with even coring down through the ice because, again, it's massively expensive and very difficult to do. So if this hypothesis is correct, this is an amazing insight into past Antarctic sea ice dynamics. And that's exactly what my supervisor, Erin McClement, did, and the team at ANSI, at Durham and Bass. They looked through deposits from several sites in Antarctica, and they were able to show that it did record shifts in the sea ice in the region. So what they wanted to do, as a result of that, is get a better idea of what the snow petrels are doing today, so we can then trace that back into the past. And that is where I came in. My PhD is to look at the modern foraging ecology of these seabirds. So I was incredibly lucky that I was able to head down to Antarctica this time last year. So this time last year I was a lot colder, and spent just under 2 months there as part of my PhD research. So, the fun stuff. To get to Antarctica in the middle of a pandemic is interesting. We flew from London to Cape Town, and then we spent 3.5 weeks in Cape Town praying that we would actually be able to get to our station, because we had to quarantine, and then we had weather delays. And it's a very, very strange feeling to be in a ridiculously beautiful place surrounded by wildlife, absolutely terrified that you're going to have to stay there. After 3.5 weeks, we got onto a flight and we flew to Novolazareskia, which is a Russian airbase right on the edge of Antarctica, so it's only about 70 kilometers from the coastline. And we got stuck there by the weather. That's okay, the Russians were very hospitable. And being a vegetarian in a Russian base is awful. Then to get from Novo to Princess Elizabeth, which was the base I worked at, we were able to take just a short flight. So the flight from Cape Town to Novo was about 9 hours. And then it took us about 3.5 hours to get to the research base that I was going to be working at, which was Princess Elizabeth Station, which is a Belgian base operated by the Belgian government and the International Polar Foundation. Getting there, this is a little bit of nerding out about airplanes, I do apologise, but the first flight we took was this. This is an old Russian carrier called an Ilyushin. So despite the fact that these look massively clunky, these are one of the smoothest planes you will ever be on for landing and taking off. It's very impressive. And the cool thing about them is you'll see the front of the nose of the plane has windows, so that you're able to check out what's beneath you. And as someone who studied sea ice for a year, having not seen any, getting my first glimpses as we flew across the ice edge in Antarctica was a really amazing feeling. So this was my first look at what I've been studying for a very long time. The inside of the plane doesn't have seats or anything like that. We weren't actually passengers, we were classed as luggage accompaniers, I think. And you're just sitting staring at a group of Russian men. I include this picture because the man on the right did not move or change his clothes for 9 hours. And when we left Cape Town, it was quite warm. So yeah, that was the entertaining bit. And the best bit about that plane was that was the toilet. And it was not very well strapped down, so every so often it would move and everyone would get very tense. When we arrived at Novo, so we landed on this runway here, so you can see there's just big chunky wheels on the Illusion aircraft. And this runway at Novo, this is basically Antarctica's airport. This is kept very well maintained, so we were able to land there. After a few days at that airbase, Novo, we got onto this airplane here. This is a DC-3. For anyone who likes their aviation history, this is Lydia. Lydia is a very famous DC-3 because she crashed in Antarctica a few years ago. So this plane itself spent a winter completely embedded in the ice. So she was put nose first into the ice. Everyone survived. It was fine. And then the same person who crashed her flew her out the next year. And they did not tell us this until we'd landed, which I was quite glad about. But you'll see that the DC-3 actually has skis because this is designed to be able to land on runways that aren't quite so well maintained. And it is a bumpy landing, but it is a lot of fun. Then we got to the station we were going to be at. So you heard me mention the word Nunatak, and you'll see this rock protruding out from the ice. So this would be an example of a very low relief Nunatak. So below this, the ice was actually about 2 kilometers thick. So this is the top of a mountain range here. And Princess Elizabeth is a base that's actually built onto that rock itself. So it is a very special base. I'm going to tell you a little bit more about it shortly, but just to see in this video, you'll see we have wind turbines along here. We've got some massive generators in those blue shipping containers. And then you will see a lot of vehicles. But the thing about Princess Elizabeth is that this is Antarctica's only zero emissions base. So it is completely powered by wind and solar. They're the airstrips that we landed on. In the background, and my field site is very nicely out of shot there, but I will show you what it looks like in just a few minutes. So yeah, again, this is the greenest station in Antarctica. And this is what people are really hoping that all stations in Antarctica look like in the future. So the only fuel, like diesel or petrol, there is currently, it's used for the vehicles. So we travel by Skidoo on highly modded Hiluxes. The season I was there, so last year, they actually tested the first Antarctic vehicle, the first electric Antarctic vehicle. So hopefully in the coming years, it will be a highly clean base. That's not just important for the climate itself. I don't think I even need to explain that element of it, but it means that certain scientific activities can be carried out there where they're looking at stuff like the atmosphere around there, because you're not going to have the contamination from big sort of diesel fuel generators around the sites. It also meant it was a very quiet station at times, which was lovely. The only issue was the water all got put through a bioreactor, so it was bacteria that was cleaning the water, and that produced something known as the sludge, and that smelled quite bad. But after a few weeks, the seabird scientists smelled a lot worse, so it was okay. The mountains that you can see in the back of that photo are the Sorondane Mountains. So this is the mountain range for my study area, and they have a vaguely east to west trend. They are not by any means the tallest mountains in Antarctica, but they are incredibly beautiful. So when we first got to Princess Elizabeth, the first thing we went for was obviously safety training. So we did a lot of crevasse rescue. We did vehicle maintenance for the Skidoos, for example. We had a lot of medical training before we went, and we did more when we got there. Medical training in Antarctica mainly consists of please don't get hurt. We are very far away from anywhere. But it is an absolutely invaluable element of travelling to Antarctica, because when you're there and you're really thrown into the science, it can be hard to forget how inhospitable it really is as a continent. So you'll see a lot of pictures of the beautiful blue sky days, but when Antarctica has a whiteout, it truly has a whiteout. There were days where we were stuck in the base and we weren't able to leave certain buildings, let alone leave the site itself, because the winds were so strong. At a base just about 1,000 kilometres away from us, I think the day I took the photo on the right, the wind was so strong that it was actually picking up rocks and throwing them against the side of the shipping container. So what you can see in the foreground of the picture on the left is one of the huge big snow machines that was constantly out in pretty serious conditions, just moving snow away from the main doors just to make sure we always had some sort of access to the primary part of the base. And there was, as you can see, it's a Belgian base, but a flag went up for every new nationality that visited, and I was very honoured to be the reason why they have their first Irish flag. So yeah, they did accidentally order a massive one, so the Irish flag ended up about 4 times bigger than everything else, but I wasn't complaining. And this was me realising quite how cold it was when I bit into a Mars bar on my first day in the field and nearly broke my tooth because it had frozen solid in my backpack. It's not quite as impressive as the flag, but so hey. Now, as I said, my field site was just behind the station. So what you're looking at the left there, that mini little mountain is called the Coastline, and that is where the Snow Petrel colony that I worked on is. So it looks like it's very close in that picture, but the thing is, just down along the frontier, this is a crevasse zone. So we actually had to leave the station and skidoo for about 15 minutes and do a big loop before we came back to the Nunatak itself. And then we would cramp on up and we would climb to our station every day. So there was a lot of travelling around by skidoo, which, although I know it isn't wonderfully environmentally friendly, I adore. That was a daily, was what I called my skidoo. So this was the view once we got down into the Nunatak. So just behind it, there's a massive big wind scoop, which is when the wind comes down and carves out the ice sheet and makes big snow banks and ice banks. And so, as if you're standing here, just to give you some context, you're looking directly back towards the station. So if you came up, climbed up around there, and headed straight that way, you're back at that station. This is what most snow petrel colonies will look like. So they're going to nest in amongst the scree, they're going to go in under boulders and little gaps in the rock itself. And the view was absolutely phenomenal, and it made up for the fact that we did have to climb it every day. And here in the background is Viking Ogda, so that is the tallest mountain in the region. So what we would do was we would head around all of these boulders, and snow petrel colonies aren't like other seabird colonies where you have this engulfing cacophony of the seabirds crying. They're very, very quiet. Sometimes your only indication that there's a snow petrel there is you're walking along and then suddenly your ankle feels a little bit warm, and it's because a chick has decided that you were a threat and has spat on you without making a noise. When you do hear them calling to each other, they make quite a guttural croak. I played it for Tal for the first time, and I think she was very disappointed because they don't have what's necessarily a pretty call, but I love it. So just to put into context, when we were there, snow petrels again will have a winter migration where they only are at the colony during the austral summer. So their chicks will leave the colony between March and April, so around then the colony will empty and you'll only get the odd male who'll come back during the winter just to check everything's still all right, or for whatever reason they do, for nest defence, for example, and they will spend the winter out at the edge of the sea ice, and so they'll roost there and they'll feed there and they'll go through a very gradual molt as well. Around October they'll start coming back to the colony, so again it's the males which will usually come back first. And then they'll breed around the end of October, start of November. In seabirds, you have a phenomenon known as a pre-laying exodus, and what happens here is once the female has conceived, she will fly out to sea and she will spend the time foraging and building up her energy reserves to grow her egg and her chick, and that in snow petrels lasts about 3 weeks. Then they'll come back in early December and they'll lay around the end of the first week of December. Just realised I could be showing you pictures. They'll lay around the first week of December, and then they'll spend about 40 days sitting on their egg, incubating it. So we arrived just towards the end of incubation, so we were seeing snow petrels on eggs. And then around the first week of January, they'll start to have their chicks, and this is the view you have of the chicks for the most part. It's just this tiny little grey bump poking out from underneath its parent. They are absolutely gorgeous, as are most seabird chicks, but snow petrels are something else, but I might be a little bit biased. And you'll hear the chicks in constant communication, very quietly with their parents at this stage. And for 2 or 3 days, you'll always have at least one adult remaining with the chick. It's called brood guard. Then the chicks will reach thermal emancipation, they'll get bigger, they'll get fluffier, and they'll be able to rest on their own at the nest sites. And this is when they're at their greatest threat from skuas, which are big predatory birds. And we had a breeding pair of skuas at our colony, which were absolute menaces for both taking our crampons for some reason when we set them down. They loved the crampons, but also unfortunately taking the snow petrel chicks as well, and sometimes adults. So this is what we were seeing. So that's a bird. Actually, every bird in these photos has a chick with it. The one on the left is completely covered, and you see the tiny one in the middle. That photo was actually the first chick we saw in our season. It was January 16th. And then you can see they'll be poking out their little heads. All of that wax that you see surrounding them is stomach oil. So these birds will nest in, again, millennia's worth of regurgitated vomit from their forebears, which is either gross or a bit metal, depends on how you look at it. The next slide can be a bit gory. I have spent some time talking about sick, so it should be a way of warning you. But as I said, there was skuas, and you don't get normal erosion in Antarctica, so everything that is killed there remains there. So at the base of the Nunatak, so down at the bottom of the mountain, you are just walking across plains and plains of snow petrel bones and bits of eggshell fragments and skulls. What I always found sometimes quite hard to see was that you get the chick embryos, which from failed eggs will freeze and pop out. You'll get frozen chicks, again, they don't have a massive, well, for most seabirds they have an all right chick survival rate. And then you'll get, anyone who's worked with skuas will recognise this. This is a pellet from a skua, and it's got a full snow petrel leg in it. Most, enigmatically though, are these angel wings, and these would just be completely dotted around the colony. So this is from the skuas, again, only eating the meaty keel and the head of the petrels. So it was hard to see, but it's also amazing because some of these bones were just completely bleached white, and again, they could have been millennia in age. So my main reason for being there was to put little tracking devices on the snow petrels and collect some of their modern diet, but what I was also doing was collecting some more stomach oil deposits, which was great because that meant I got to go off climbing and hiking and find as deep a deposit as I could possibly find of this old waxy vomit and then hammer it out, basically. So this again is on Viking Ogda. And what I've got on my back in this photo is 24 kilograms of hard snow petrel vomit, which is a deposit that we've really enjoyed working on for the past year or so because there's been some really, really cool stuff coming out of it. So watch this space for that. And I will say that that hill is a lot steeper than it looks in that photo. But yes, that was a huge element of my fieldwork, was to collect as much of these deposits as possible and then ship them back to Durham for analysis. But for the focus of what I was doing, I was putting these little GPS tracking devices onto the tail feathers of the snow petrels. So these only weigh about 2 grams, 2.3. They're incredibly light. They've been proven in previous studies to not have maladaptive effects on the birds. And what they're taped to is tail feathers that they will naturally molt out over the coming months. So they were only on the birds for a few weeks. And it's got a wee little solar panel on the back. So these were solar powered devices. So we attach these GPS devices to the snow petrels. They head off out to the ice, to the edge of the sea ice for feeding. And that device is talking to satellites and recording a position every 20 minutes or so. Once the snow petrels return back to the colony and they come within line of sight of this base station, that tag is going to transmit to that base station, and it's going to give all of the information for where those snow petrels have been. And what we can do then is create a track, and we have timed locations for these birds every 20 minutes for, I think our longest track was about 14 days. And you can see these snow petrels were travelling 200 kilometres to the coastline, and then they would feed, and then they would head back. So it was absolutely awe-inspiring to see these tiny little birds. They're very small in the hand, they're only about the same size as a pigeon, and knowing that they had made these vast journeys out to these incredibly inhospitable areas. Now, we have these trips, but we have to see what we can get from them, what's useful. So we know the snow petrels have been in X amount of places, but we don't know, are they feeding there? Are they resting there? Are they just stopping, having a look around? We're not sure. So in seabird science, in marine ornithology, what we do is we take the tracks that these birds have, and then we characterise them based on a certain set of principles into, are these birds putatively foraging, are they resting, or are they commuting? So the idea is, if you were looking directly down at a seabird foraging, if it was going in lots of little loopy things, taking lots of tight turns, making lots of short trips, it's probably not commuting anywhere directly. Sounds like it's more looking for something. So we would characterise that behaviour as foraging. If the bird doesn't seem to be moving, if it's just moving along maybe so slowly it's possibly the same speed as the current, we'd assume it might be sitting on water or it might be sitting on an ice floe. The bird is probably resting or roosting. And if the bird is persisting in the same direction for even several hours, we could assume that that bird is commuting. So it's heading between 2 points or even back to the colony. This method is known as a hidden Markov model, so it's hidden because we don't actually see what the birds are doing. But it's a really useful way of taking seabird tracks. So to summarise, what my research entails is putting these tracking devices on the birds to look at where they're going. Then another element of my PhD, which I haven't properly gotten into just yet, is looking at feathers, bloods and diet samples, which I collected when I was down there to work out what they're eating. So then comparing those two things and saying, okay, when they go to this kind of environment, what are they eating? If they're eating this, are they in this level of sea ice or are they at this depth of water? And then looking at the stomach whale deposits and relating that to sea ice conditions in the past. And I think that is all I have. Oh, from the most important parts, apologies. Just a very quick thank you to Stephanie Prince, who came into the field with me last minute and absolutely saved my fieldwork when a colleague had to pull out, to IPF and MPI, who provided the field sites for us, and especially Dr. Henri Robert at PEA, the lovely ANSI project team, and the European Research Council for paying me to do amazing things. If you'd like to know any more about this, we've got an ANSI website, and also happy to chat to anyone on Twitter or after the talk. So yeah, Gurmila Mahagat, thank you very much for listening. I'm happy to take any questions.